is astaxanthin the most powerful natural molecule to extend not only your lifespan, but also the quality of those years, also known as health span. In this episode of the Mind Body Peak Performance podcast, we explore topics such as what is astaxanthin, why is it so important, where does it come from naturally in the diet, the clinical benefits, as well as the potentials that are conserved across different species, from plants to animals to most likely humans. We go into how it works inside the body, the safety and or potential side effects, dosing, the great debate whether natural versus man-made forms are best, the most common uses and outcomes people tend to report from using astaxanthin, and perhaps most importantly, what to look for in high-quality products. Because when I did my own research and looked into the purity and potency of a lot of the options on the market, I was quite frankly disgusted that so many of the different products out there, the different supplements, claim triple potency, triple strength, and they actually come back with less than 1/12 of that triple potency claim. If they advertise 12 milligrams and you get less than 1 milligram, it gives you a false sense of confidence and you're not actually getting the benefits of this substance. You can see my analysis of astaxanthin by typing in outlier, OUTLIYR, astaxanthin. You can put that into any search engine, and from there, there'll be a link to each of the different products for your budget and different use cases. If you feel so compelled by the end of this conversation and want to give our guests' astaxanthin product a shot, it's the one I'm using. It's called AX3, and you can use the code URBAN to save 20% on your order. All of these will be in the show notes for this episode, which you can find at mindbodypeak.com/187. Joining us today is Dave Watumull. He has 25 years of experience working with astaxanthin, making him one of the more knowledgeable and experienced people in this field. Astaxanthin is a marine supernutrient with important health and specifically longevity benefits. Dave is the co-founder and CEO of a company called AX3 Life, as well as the life sciences branch, which is called Cardax. If we lose you with some of the scientific details, don't worry, I do my best to summarize the most important parts of it during the conversation. One of the questions we didn't have time to discuss together is, if you actually look into the research around astaxanthin, why are there conflicting results, especially when it comes to the role on athletic performance and recovery? From my own research, I discovered that's because that some of the researchers who designed these studies didn't use the right dosage, the right sample sizes, or the right duration of use to observe the expected outcomes. Of course, like every molecule, more research is needed. But what I love about it and why I've used this for many years now is because of the therapeutic potential to the safety and toxicity. This is one of those molecules that shows a lot of promise and at the same time appears pretty dang safe. Okay, with that out of the way, sit back, relax, and enjoy this conversation with Dave Watumull. Dave, welcome to the podcast.
Hey, thanks for having me.
Today, we're going to be discussing a fascinating molecule that's started to get a lot more attention of late, but a lot of us in the alternative health and supplementation world have been either using or fascinated by this molecule for a very long time. Before we go into what that is exactly, what are the unusual non-negotiables you've done so far today for your health, your performance, and your bioharmony?
Wow. Okay. Well, I got a good night of sleep, and I found that getting a bowl of ice water is a great way to, dunk my face in and get refreshed and wake up. I worked out, kind of a high intensity training, and that felt really good. Had a nice protein, creatine, BCAA recovery drink and lots of water. And then kind of got into it. So that's been my morning so far. And I'm here based in Hawaii, so it's mid-morning for me. So that's been my day so far. But that's a nice way to start the day, and try to do that as often as possible.
I like it. Have you taken any antioxidants yet today?
Let's see. I have not. My antioxidants would be astaxanthin, like we're going to be talking about, but I'll be taking that with the meal. I haven't eaten yet, and I'll also, consume other nutritional drinks or green drinks that do have antioxidants and other great ingredients in them as well. And so that would probably come in the next few hours. Yeah, hopefully coming soon. But
Yeah.
yeah, definitely throughout the day, dosing up on that.
Well, I got you to say the magic word I wanted you to say, which is astaxanthin. And
Yeah.
that's a bit of a tongue twister for people who've never heard of it. But what is it and why are you fascinated by it?
Yeah, astaxanthin, or ASTA for short, is a naturally occurring molecule. It's commonly found in the marine environment. And even though, like you said, it's hard to pronounce, most people haven't heard of it, I can guarantee that almost everyone has consumed it because it's what makes salmon pink and lobsters and crab red and pink, shrimp. So most people have eaten this throughout their lifetimes. It's been part of the human diet for thousands of years, and it's part of the carotenoid family, which is a really interesting group of colorful, pigments, molecules that you'll find in vegetables and fruits and plants, and so these carotenoids co-evolved with plants, millions of years ago, to help plants as they dealt with photosynthesis. And as they were evolving photosynthesis, they needed to deal with the damaging effects of the UV light from the sun. So they use the sunlight for photosynthesis, but there's also negative effects that they need to counteract. And also there's other aspects in terms of energy storage that they utilize the carotenoids for. And so the whole family of carotenoids evolved over time. One of the famous carotenoids is beta carotene that a lot of people would know of. Lycopene is another that is fairly common. And astaxanthin is a special part of a special subclass of carotenoids called xanthophyll carotenoids, which are oxygenated, which from a molecular standpoint means that they have like an oxygen, a hydroxyl group on the ring moieties of the molecule that gives it key differences versus beta carotene and other carotenoids. And so as you look at the evolutionary tree of carotenoids, nature tinkered with the different forms and ultimately ended up with astaxanthin as the apex or the king of the carotenoids because it appears to work the best. So we certainly believe. And so this molecule that gives these species their beautiful coloration actually is so much more than just pink. It is something that gives them really potent health and vitality benefits. And if you look at salmon, for example, we're all familiar with their swim upstream to reproduce, which is a beautiful miracle of nature as they're swimming upstream, going up the little kind of waterfalls and battling off bears and trying to get to the ponds to reproduce. But if they didn't have astaxanthin, not only would they be gray rather than pink, but they would be smaller, prone to infection, have problems reproducing, and be too weak to swim upstream. And so it's really vital for their life and their reproduction to have astaxanthin. And when salmon, we think of the flesh as being a beautiful pink or red color, but when they're swimming upstream, their skin actually turns red, and that's the astaxanthin transferring out from their flesh to their skin, which potentially might mean that they're ready to spawn. And then ultimately, when they do reproduce, the astaxanthin is transferred to the eggs. And so that's why the salmon eggs are red, and it helps with the development of the offspring and also the protection because they lay their eggs in the shallow waters in those in the springs there, and the sunlight hits the eggs, and the astaxanthin helps to protect them from that. So it's this really amazing molecule in nature. And about 25 years ago, I got into the space and we started to look at the benefits in terms of, well, how does it actually work? And that was kind of started this whole journey that we've been on ever since.
Very nice. And it's cool to look around and see the different ways a substance is used in nature, such as by plants to protect them from the UV light, and then also from salmon and other fish and seafood to do the same thing. And then also looking at humans, and some of the early interest in astaxanthin was around its ability to help protect against the damaging effects of UV. And since sun exposure is both getting more popular in terms of absolute exposure and total duration, and at the same time, it's getting demonized more for its potential, in my opinion, overblown link to skin cancer, at least in moderate, reasonable doses. And if you've built a solar callus and all that, it's interesting to see how the effects in nature parallel the effects in humans.
Yeah, for sure. And I think like with everything, it's all about balance and moderation. And so, some sunlight exposure is great. Too much is not good. Too little is not good. And the data definitely supports that astaxanthin does protect against the damaging effects of UV light, against DNA damage. There's even human studies showing benefits with reductions of wrinkles, improvements in skin elasticity and moisture content. And that's both oral and topical administrations of astaxanthin. So it's definitely something that can benefit skin health. And but it's not a replacement for sunscreen, which technically from the FDA is regulated as a drug, which astaxanthin is a supplement. So we can't make those types of claims, and we certainly wouldn't, just because it'd be prudent to have topical sun protection as well. But we think astaxanthin definitely is a great additional benefit for your skin. You'll find it in some cosmetics in very, very low concentrations, but just taking a nice dose orally does give you, because it's distributed systemically throughout the body, a great benefit for skin and other vital organs.
Yeah, about 8 or 9 years ago, I started experimenting with it to help protect me when I was under the blazing hot sun playing rugby and other sports, often outside for 4 or 5 hours a day during the middle of the summer and different seasons. And I noticed that I was more protected against sunburn, even though it's not a drug, it's not sunscreen, that I didn't burn as fast. And that was also paired with a bunch of other things, such as getting some of the plant pigments, I think they're proanthocyanins, and then also the shilajits of the world, and using a bunch of different things combined with a low PUFA diet, that I was able to not burn as fast.
Yeah, that's great. And so you'll find a lot of those types of testimonials, out in the community with the users of astaxanthin. For example, a lot of the triathletes in Kona, the Ironman triathletes, have used astaxanthin for decades. And so that's probably for a combination of benefits ranging from the skin support, but also the endurance and the recovery and all of that. Kind of like the same thing like with the salmon swimming. It helps them and it helps the triathletes as well.
Yeah. The marketing around astaxanthin that I've read tends to focus on its antioxidant power, and it's often compared to other known antioxidants that people usually supplement. And I know it's a lot more than just an antioxidant. We'll talk about that in a second, but can you rattle off some of the numbers about how it compares to other popular supplements?
Yeah, and so those are based on taking astaxanthin and taking other common antioxidants and comparing, singlet oxygen quenching or other types of antioxidant, capabilities. And there's various published literature on these things, and you'll get various scores on the efficacy of those studies. And astaxanthin was shown to be, I think, like 6,000 times stronger than vitamin C, and I'm not looking at the numbers, but it was hundreds of times stronger than vitamin E, maybe 500 times stronger, and like 40 times stronger than beta carotene. And yeah, you can check our website or other published papers for those numbers. But those are great from like a marketing standpoint, just to say, look how powerful this antioxidant is. But the more important thing is that not all antioxidants are the same. And it's not just a matter of, well, how potent of an antioxidant are you? It's really important to look at where does the antioxidant go in the body, and where does it go specifically in the cells? And then when it's in the cells, what is it doing? How is it localizing? Vitamin C, maybe, not actually in the membranes, for example, being, water soluble. Whereas if you have, say, like vitamin E or beta carotene, lipophilic, you'll find those in the cellular membranes, which are comprised of lipids. And so with astaxanthin, it gets into all your major organs, you distribute it systemically, gets into the cells, And importantly, it gets into all of the cellular membranes, which is the outer membrane of the cell, the plasma membrane, but also the membranes around all the other cellular organelles. So the nucleus has a membrane, the mitochondria have membranes, the other important components of the cell have membranes. And so it gets into all these membranes. And importantly, and we've done work with a collaborator of ours who has a professorship appointment at Harvard and also his own research company that had this really cool biological membrane model where they could look at a model of a membrane, incorporate different molecules like astaxanthin, and actually look at if those molecules are disrupting the membrane at all based on the distribution of the electrons in that membrane. And with astaxanthin, because of, if you recall, I mentioned it's part of the xanthophyll carotenoid family and it's oxygenated, that gives it these polar head groups, which allows it to span and anchor across the membrane with the polar heads of the lipids in the membranes. And so if you look at a cellular membrane comprised of the lipid bilayer, astaxanthin spans perfectly across the membrane and doesn't disrupt the phospholipids in the membrane and keeps that nice ordering. And that's something that's really important because if you disrupt the membrane, that can have a whole host of negative effects. And if you look at beta carotene, which does not have those polar head groups, it gets into the membrane, but it is not spanning it and stabilizing it, and it disrupts the membrane. Same thing with vitamin E, which doesn't have the two polar head groups like astaxanthin does. And so with that, you have a stabilization of the membranes, in addition to its very potent antioxidant, capabilities. But it's also scavenging free radicals, functioning as an antioxidant both inside the membrane and outside the membrane because it's basically perfectly spanning across. And so it's there to fight off free radicals with its kind of conjugated polyene backbone of the molecule within the membrane, and then the head groups of the molecule that are at kind of inner and outer edge of the membranes are also well situated to trap free radicals. And with that, in that same study, in addition to not disrupting the membrane, it had a nice reduction of lipid peroxidation, which is the oxidation of the lipids in the membrane. Whereas the others, like beta carotene, could actually have a pro-oxidant effect in that case, where it was causing an actual increase in lipid peroxidation. And so that's where a lot of people may paint antioxidants all with the same brush and think, looking back to old studies with beta carotene and saying, oh, it looks like beta carotene didn't work, therefore antioxidants don't work. But that's not necessarily the right conclusion or extrapolation there, because again, astaxanthin functions very differently.
Interesting, especially the lipid peroxidation part, the prevention of the fats breaking down, because that's one of the big reasons people supplement vitamin E, especially after eating certain highly rancid and oxidized seed oils. They're so common at restaurants. So it's cool to hear that astaxanthin can help protect against that. And overall, there's a whole move towards cellular health as a core pillar of overall health. And if your cell loses its polarity, you can no longer maintain that same charge inside and outside of the cell, then none of the processes work as well. So if you start by fixing and improving the contrast from the membrane and the barrier, then everything's going to work better.
Yeah, I mean, that has an impact on cellular health is the foundation of everything, where, all these different cell signaling pathways, are all, influenced by that overall cellular health. And then if things are out of balance or not functioning properly or unnaturally being inhibited or activated, and then you have different issues that manifest themselves over time. And it could be in one organ or another. It may look like a joint issue or a heart issue or a cognitive issue. And then with modern healthcare, it'll get attacked with, a particular drug or, procedure where you're trying to kind of whack-a-mole and fix this thing and then fix that thing, but you're not actually fixing the underlying issue at the cellular level. And so it's bound to have side effects or other long-term issues. And so it's more about dealing with the root cause, of health issues and trying to hopefully maintain health rather than trying to fix things after, they fail.
Yeah. And anything that can improve the mitochondria, the energy production factories, even though I hate that term, of the cell. And then we have hundreds to thousands within each cell, and reduce the amount of like metabolic waste, the reactive oxygen species, reactive nitrogen species, all that stuff that is produced is going to benefit a lot of different organs and systems throughout the body. And it's cool that we see that with astaxanthin. And yes, it helps all kinds of different things. What are some of the different organ systems that we see and overall benefits?
Yeah. So, well, first of all, I'll just touch on the mitochondria, just because you mentioned that. And so, the fact that that astaxanthin can get to the mitochondria is a big deal, because that's a privileged site. And astaxanthin gets to the mitochondria and helps to prevent, again, the oxidative stress, lipid peroxidation that can damage the mitochondrial membranes. And there's been studies showing that astaxanthin has a positive influence on the number and size of mitochondria, energy production in terms of the measurement of ATP, both in young and geriatric dogs, for example, as being increased, and benefits with mitophagy, which is autophagy or cellular cleanup of the mitochondria. So mitogenesis, like I said, in terms of additional mitochondrial production. And so a lot of key benefits to the mitochondria, which, like you said, are responsible for the energy production. But as a byproduct of that, you'll have reactive oxygen species, for example, that are created that can cause damage throughout the cell. So astaxanthin definitely gets the mitochondria and helps them to function, in a much more healthy way, or maintain that proper function, rather than mitochondrial dysfunction, which is definitely a major issue. And then, touching on your other question in terms of the other major organs and health applications, the fact that astaxanthin is absorbed into the liver, gets packaged with lipoproteins, LDL, HDL, VLDL, it gets packaged into those. And so, first off, in addition to accumulating in the liver, which provides liver health benefits, and we've done studies showing benefits there, it gets into, say, like LDL. And so, when you look at oxidized LDL, which we've looked at in a human study, we saw reductions in oxidized LDL, which is a really probably the worst form of LDL, because it's oxidized, and that's more prone to major cardiovascular issues. And so it hitches a ride on these lipoproteins and protects them, but uses those as transport throughout the body. And so it'll get to the heart, and it crosses the blood-brain barrier, gets to the brain. And so you see benefits in all of these major areas. And so there's been both preclinical and clinical studies in pretty much all of these different areas. If you go to PubMed and search for astaxanthin and fill in the blank, you're going to find a lot of really interesting research that's done, both preliminary, preclinical, or you might find in vitro models in test tubes. You can find preclinical or non-clinical studies in animals, which is typically used for research, because you can have experimental models that mimic diseases and give you good understandings for human applications. And then there's probably 100 or so human studies with astaxanthin. And for example, that human study that I mentioned, where we looked at oxidized LDL, was in cardiovascular subjects. So everyday people that had cardiovascular issues or risk factors, and they were already taking cardiovascular medications. And on top of that, we gave them our form of astaxanthin for 12 weeks at both a low and a high dose, and a placebo. And so this was a double-blind, randomized, placebo-controlled trial. And we showed reductions in oxidized LDL, in total cholesterol, in just LDL cholesterol, blood pressure. And when we looked at, say, subgroups, like a diabetic subgroup of the population, we saw reductions in HSCRP and triglycerides. And so it really had some important benefits there. There have also been studies in cognitive health, for example. So looking at performance on cognitive tests, where you are performing, a maze, or trying to do some type of memory or recall exercise. And you'll be graded on things like, how many questions did you get right? Or how fast were you answering? What was your response time? So information recall, memory, information processing, all these things, there have been benefits that have been shown in those areas. There have been studies looking at liver enzymes reductions there. That is a good thing for liver health. But like you said, there's skin benefits. There's eye benefits. There are other carotenoids that also are great for the eyes, lutein and zeaxanthin that actually get into the macula of the eye and are kind of like astaxanthin for the eye. But astaxanthin also has benefits for the eye, probably based on its more systemic reduction of oxidative stress and inflammation. But yeah, so the most common benefits are you'll find joint and muscle benefits. And in terms of the joint studies, there aren't a whole lot of human studies specifically looking at joint outcomes, but there are biomarkers where you look at inflammatory cytokines like TNF alpha and you see reductions there. And that translates to improved joint benefits. And if you look at the testimonials from the user community of astaxanthin products on the market for the last 20 or so years, you'll find a lot of joint health benefits. Muscles, there have been studies looking at, for example, sarcopenia, which is as people age, their muscles are prone to decline or deterioration. And there was a study with astaxanthin, not our study, but another study showing that there was an increase in muscle size and strength in that population, which sometimes there are questions about, oh, do antioxidants or does astaxanthin potentially have a negative effect on muscle growth? If you're working out and you have, hypertrophy goals and to my knowledge, I'm not aware of human studies looking at that specifically, say in adults, kind of in a normal age range, or specifically looking at bodybuilding or other forms of exercise. But certainly in an elderly population, there were benefits for the muscles. And if you look at the use in the user community from triathletes and others, I would believe that if there were a negative effect on muscle growth, it wouldn't be used so commonly in the athletic world. And then if you look at things like the salmon swimming upstream, it really helps them there. And so again, I don't think it has a negative effect there, although I couldn't speak conclusively to like a large scale human study benefiting that. But there's a whole bunch of areas that are really interesting. And if you look at benefits for kidneys, for example, you'll find things there. And so but it makes sense because of the fact that astaxanthin gets distributed throughout the whole body, gets into the cells and all your major organs, and works at that real foundational level to reduce the oxidative stress, which is its core functionality. If you look at the structure of the molecule, that's what it does physically, biophysically in the cell. But then that has this whole cascade of benefits on inflammatory pathways and other cell signaling pathways and functions. And so that's where you see all of these benefits that stem from its core antioxidant benefits.
What I found cool about it, Dave, is that it's one of very few things that can actually cross the blood-brain barrier and make its way into the brain, because the brain has a barrier there to prevent things that are dangerous or potentially unhealthy from entering, such as toxins and pathogens and a lot of other stuff. Can you talk more about how it gets into the brain and any like emerging research around what it's doing in the brain, aside from just like helping quench some free radicals?
I think it crosses the blood-brain barrier as it's hitching a ride with the lipoproteins. We've done studies looking at brain tissue in preclinical studies and confirmed that it reached the brain. Others have done the same, and so I think empirically it's been proven that it does get there. And then in terms of exactly why it gets there, I think nature found a way, and so it certainly gets there. And then if you look at cognitive, mental, brain health types of issues, oxidative stress, inflammation are implicated in virtually everything. And so if you think about this, molecule getting into your brain cells and, preventing the oxidative stress that can wreak havoc, and also having benefits on inflammatory pathways, reductions of inflammation, you're going to have brain health benefits. And then that can manifest itself with different types of biomarkers or things that you may look at for different types of areas. And there's a lot of research. If you look at neurological applications of astaxanthin, there's a lot of research in the various disease areas, which again, as a supplement, we can't claim that, oh, this could help with Alzheimer's or Parkinson's, but all of those things are driven by oxidative stress and inflammation. And if you go to the literature, there's very strong rationales that astaxanthin could potentially have benefits in those areas. And that's actually why, for the last 25 years of working with astaxanthin, I've also worked on the pharmaceutical side, looking at developing astaxanthin for prescription use, where you can have a doctor that could prescribe it to a patient for a particular area after it's been approved by the FDA for a specific indication. And so it's similar to omega-3s, where you have prescription forms and you have supplement forms, and you might have some differences in the dosing or concentrations and the production, the quality, and all of that. In our case, the production, we're doing it kind of the same way, if you will, in terms of very highly pure, very consistent. But if you were to do a pharmaceutical application, it would most likely be a pretty high dose, which may be equivalent to taking, 8 or 10 or 15 capsules a day, of the product, which is not really practical. And so you might have a higher dose that's more in a more concentrated form that is packaged into a tablet or capsule for that type of application. And so, but given that astaxanthin is a naturally occurring molecule, the whole international research community is very interested in astaxanthin. So there's a lot of research worldwide, in Asia, in Europe, in North America, South America, everywhere you'll find researchers looking at astaxanthin, and a lot of them have interest in various labs that have an interest in a particular type of area of health or disease. And so you'll find a lot of preliminary research there that's really intriguing and provides rationales for, how it could potentially have a benefit for Alzheimer's or Parkinson's or other forms of cognitive health. And so you'll find biomarker improvements or mechanistic studies. And so it's really interesting to look at the potential benefits in those areas. And then as a supplement, we speak to the cognitive health benefits and kind of if you look again at the community with testimonials or the anecdotal evidence, you'll find people talking about how they feel clearer and, kind of the mental clarity or the brain fog improvements in those areas, or I feel like I'm sharper as I'm thinking, or I feel more fresh. And so those are certainly benefits that people have reported, which are consistent with the data as well.
One use I didn't mention to you, Dave, is when I started taking it, I had a theory that this is going to cross the blood-brain barrier. And if I saturate my brain with astaxanthin, if I am playing rugby and I get a concussion or TBI, then I'll have more of a protective effect. As far as I understand, there's something called the microglial cells, and they do something called microglial priming. And the analogy I've heard used to describe is they're like chihuahuas with bazookas. And once they get activated, you can't really calm them down. And I was thinking if you did certain things in advance, such as using the right substances like astaxanthin, that perhaps you'd have better outcomes if you were to sustain a concussion. Have you read anything about that?
Certainly, mechanistically, that rationale makes sense. And we have thought about pursuing studies looking at traumatic brain injury. And this could be in sporting applications, football, rugby, contact fighting sports. It also could be for the military, for the troops, who experience that as well. And so we've pursued discussions in those areas, potentially looking at partnerships with leagues or with teams or with players. And because, like you said, if you could have this on board, it's much better to provide. We would hypothesize it would be better to reduce the potential, for that injury. Because analogously, there's been studies, looking at other, if you administer astaxanthin before a cardiovascular insult, like where you restrict blood flow to the heart tissue. And then restore blood flow, which reoxygenates the tissue. And there's actually damage, ischemic reperfusion damage to the heart tissue. If you can pre-dose and load up with ASTA prior, you can have a reduction in that ischemic reperfusion damage or an increase in myocardial salvage. And so similarly for the brain tissue, if you can pre-dose over long periods of time, in addition to all the other benefits, if you're playing sports or other things that it would hopefully provide, we would think that it could potentially help in that area. And so that would be a great thing that we think should be studied because, it's so sad to see, these things, with people that are playing sports that they grew up playing their whole lives. And say even like you look at Tua here from Hawaii, who was an amazing quarterback at one of the local high schools, has played in the NFL, and has unfortunately sustained multiple concussions over the years, and a lot of speculation about should he continue playing or not, and this and that, and it's really unfortunate that these things happen, and it's something that combination of proper safety procedures and protective equipment, of course. But if there are things like this that could potentially help, I think that definitely warrants studying. And so we are pursuing those things and would love to see research done in those areas.
I also noticed as we've been discussing this that the areas it seems to disproportionately benefit tend also to be the highest in mitochondrial density, such as the muscles, the heart, the brain, the eyes, the skin, and on and on.
hmm Well, again, makes sense because if it gets to the mitochondria and it's improving those benefits, then you're going to find those benefits there. That if it has more places that ASTA can go and provide benefit, then in turn you'll find more benefits manifested in those organs. So that definitely makes sense, and so I think it's the more you dig it, it's more interesting that it makes sense that would have those key benefits.
The most interesting part to me, I've left for last though, and I want to explore this in a little more detail with you because it is probably what has the world most interested in astaxanthin right now. And that is the ITP and the benefits on longevity.
Yeah, so we didn't even talk about that yet, and so you have, and there's more, right? So there's longevity benefits, and so first off, from a lifespan standpoint, you don't want to just extend lifespan without increasing your health span. And so, fortunately, with astaxanthin, like we talked about, it has all these health benefits. And so now, if we turn to speaking about the increase in lifespan, you can, also kind of carry along with you that you also have the health improvements that would hopefully prolong that health span as well. And so looking at lifespan from a preliminary standpoint, preliminary research, there are various model organisms that researchers use to look at all types of things, but in particular also aging or longevity. And astaxanthin many years ago was shown to increase lifespan in C. elegans worms, which is a common model organism, and it was demonstrated to extend lifespan in the worms. And also, there were some mechanistic follow-on studies that showed potentially how it was influencing lifespan through a particular gene that has a human analog or ortholog. And in addition to that, there was studies showing increased lifespan in fruit flies and also in yeast. And then you coupled that with looks at the mechanisms of aging, so various cellular signaling pathways or cellular functions that have shown benefits. So you see reductions of oxidation on lipids and proteins and DNA. You see, like I mentioned before, increased autophagy or cellular cleanup. You see reduced cellular senescence or the zombie cells, if you will. You see reduced apoptosis or cellular death. And then you see impacts on key longevity pathways. So AMPK, which has an influence on mTOR, the target of rapamycin, the sirtuins, FOXO3, NERV2, and others. And these all, in turn, are what lead to the benefits in terms of autophagy and mitophagy and mitogenesis and all these benefits that are sometimes correlated with caloric restriction or other forms of increasing lifespan. And going back to that worm model, they have a version of the FOXO3 gene that's called something different in the worms. But when you genetically knocked out that gene, so they no longer had it, then the lifespan benefit went away. And so that gave us the indication that, okay, their version of FOXO3, when it goes away, you no longer have lifespan benefit. So it would appear that one of the key reasons that you're extending lifespan is via the FOXO3 gene or pathway. And so we collaborated with researchers here at the University of Hawaii that are world-renowned geroscience researchers, and were involved in the Honolulu Heart Program, which was a really amazing study that perhaps you could cover sometime in a separate podcast. But they followed Japanese American men, thousands of them, for decades, and looked at all their doctor's visits and the reasons they got sick, the reasons they died, tissue, plasma collections, and so it's this amazing database that a lot of key insights have come from, including the role of FOXO3 as an anti-aging gene, which was shown in this study to have a really profound impact on longevity. And we all have the FOXO3 gene, but there's different versions of it that are kind of basically more or less activated. And if you have the most activated version, if you will, you're 3 times more likely to live to 100 healthy. And so that really put FOXO3 on the map as an anti-aging gene. And so this research team at the University of Hawaii had a model looking at FOXO3 in rodents and seeing if with astaxanthin administration, if you would increase the expression or the activation of FOXO3. And we found that it did, in fact, that astaxanthin did increase FOXO3 specifically in the heart tissue. And so that was really exciting to confirm it in a mammalian model. And then that led to the interventions testing program selecting astaxanthin that we supplied for inclusion in their program. And the ITP is an NIH funded program, specifically within the National Institute on Aging, which is one of the institutes at the National Institutes of Health. And they're specifically focused on aging and Alzheimer's and longevity research. And so this program has been around for 20 years, the ITP, and it's conducted at 3 independent research institutions, the University of Michigan, the University of Texas, and Jackson Labs in Maine. And they have specifically bred mice that are genetically heterogeneous, which are more likely to have meaningful translation to humans versus the typical inbred laboratory strains of mice that are used for research, but don't necessarily translate well to real world human life. And so they have these specific mice that are bred for the program, thousands each year. There's a new cohort every year that they start in the ITP, and they'll select 4, 5, 6, 7 agents that have promising longevity benefits based on preliminary research. And these could be drugs that are repurposed, like rapamycin, metformin, which were tested in this program. Could be supplements like astaxanthin or green tea or curcumin. It could be other things that are of interest, like NAD precursors, like NR. And so they'll test various things, and they'll look at these mice and they'll see, okay, if we give them this as part of their feed, they'll have a control group, and then they'll have all the different test agent groups, and they'll see how long they live, and they'll compare the results, and they'll do it in triplicate at all these 3 sites where everything is held exactly the same as to the extent possible, same amount of food, the same lighting, the same air, everything the same handling conditions. And with astaxanthin, they started dosing when the mice were 12 months of age, which is the equivalent to around 40 years or so in humans, so middle age. And it turns out that astaxanthin extended lifespan, specifically in the males, by 12%. With very high statistical significance. The p-value was like 0.00 something. It was very, a strong p-value. So it means it's very likely that the results are true and not by chance. And then in the females, there was a 3% increase in lifespan, although not statistically significant. But the females already lived about 9% longer, and so it almost allowed the males and females to live the same duration. It's interesting to speculate, why in the males versus the females, but the fact that it had a overall benefit in the group, and specifically in the males, that allowed them to catch up with the females was a really interesting finding. And it was, in fact, the first supplement in the 20-year history of the ITP to extend lifespan by more than 10%. And the other things that have, like rapamycin, are repurposed drugs, essentially. And these are things that have potential safety and tolerability issues. There's a lot of interest in rapamycin. People are trying different dosing regimens and protocols, and analogs called rapalogs. Just because it does have a very profound impact on lifespan, more so than astaxanthin, most likely, it appears, based on the numbers. But again, with astaxanthin, you have the excellent safety profile and tolerability profile that you could actually take this every day, and it would be a good thing. And if you were to translate, we didn't know for sure until you did a human study, but a human study with lifespan would take decades, to do. And so it's not really practical, in any a reasonable period of time to get human data on true lifespan benefits, other than potentially looking at end stage of life, extension by, a couple of years. So if you're looking at taking people that are, young or middle age, or starting to get into older age and then following them, that's going to be years and decades. And so that's why they do the mammalian rodent model. But if you were to translate the benefits from this study to humans, it could potentially be like another decade of lifespan, which is very meaningful to live another decade. And given all the health benefits that we know about and the safety, that's a really, really big deal and really exciting. And that's why we were so excited when this study was completed and published last December. And we were excited to be a part of that. Our researchers at Hawaii, at the University of Hawaii, proposed that the ITP select astaxanthin, and based on their research and the other preliminary research, that the ITP selected it. And then we worked with the ITP research team to supply them with the astaxanthin, and also help them figure out the right amount to include in their feed for dosing, and also the analytical methods to measure, so they could detect how much astaxanthin was being absorbed into the mice in a preliminary study before starting the main study. And then we ultimately helped them when the study was published with some of the discussion around astaxanthin in the paper. So we're co-authors on that paper that was published in Geroscience last year. So that was a really big deal. We're really excited about it. And I think it really confirms or validates that astaxanthin is in there in terms of a longevity, molecule of interest. And so there's a lot of hype around rapamycin. There's a lot of hype around other things like NAD precursors. Although, like I said, NR was tested, did not work. Metformin was tested, did not work. Rapamycin was tested and did work multiple times. So that one definitely has, some very, promising results. There's been other agents that have been tested that are other like diabetic types of drugs that seem to have benefits. But fish oil was tested, didn't have a lifespan benefit in this model. Curcumin, green tea, resveratrol, which is another very popular one that goes kind of in and out of vogue, but also didn't, extend lifespan in this model. And so it's not to say that these other agents don't have other potential health benefits or maybe have mechanisms of impacting longevity. But in terms of the ITP, which is by all means the most rigorous, probably gold standard mammalian model of lifespan, they didn't extend lifespan, and astaxanthin did. So I think astaxanthin should be, when people are talking about what are the top agents, not even just supplements, but agents, things that you could take potentially to improve lifespan and health span, astaxanthin I think is definitely confirmed to be part of that discussion now.
Yeah, I'm with you on that. And I was looking through the database earlier today, and I noticed that a lot of the more popular things, substances, drugs, supplements, all of them had no effect in the ITP trials. And astaxanthin is one of the few natural substances that's not only safe enough that you could take dosages multiple times the daily recommended amount and be just fine, versus if you took, say, rapamycin, you took 3 times, 4 times the recommended amount, you're playing with fire at that point. That is pretty dangerous. And it also has a very long half-life. So it's like dosing that, like immunosuppressive substance like that is that powerful. Then you have to figure out how to combine it with your workouts, and you have to figure out how to mitigate side effects and all other types of things.
Yeah, it's very challenging. I mean, you're taking a drug that's used, for organ transplants to suppress the immune system, so your body can hopefully, take on the new organ and not, fight it off, and so that's a very hardcore substance to be putting in your body, and is probably not how your body was meant to function. And so with astaxanthin, we like to think of it as helping, to restore homeostasis or cellular balance, and kind of restore normal working order and function. So this isn't like something that's going to turn you into a superhuman and allow you to live to 180 or something, but this is more like, okay, let's maximize the years that we could and should have, because a lot of us are doing everything, to not do that in terms of lifestyle, with diet and exercise and sleep and stress and environment, all these things negatively impact. And so you should take all those steps to improve all these other areas. But in addition, if you can have astaxanthin, then the research would support that it could help you improve your lifespan and health span, in addition to just, and it doesn't just mean that as a longevity agent that, oh, this will help you when you're old. This is something that, aging is an ongoing thing. We're all aging every second. And so, if you can maintain, your level or improve it and over time, that's a really great thing. Because a lot of people like you said, okay, I used to play rugby, and I don't know if you still do, but a lot of people, obviously contact sport like that, maybe people maybe don't play it forever. But a lot of people, whatever it is, they'll stop playing the things or doing the things that they love to do, and that's not great for your physical, manifestations, for your mental faculty. I mean, you want to be doing things, and not just sitting and being sedentary and watching things, happen. And so this is something that could allow you to continue to live your life, in a way that hopefully allows for great fulfillment and overall health.
And I want to underscore you were saying a second ago about the ITP. The reason that I find it so fascinating is that there's a lot of really cool studies out there, a lot of cool headlines about this new supplement increases lifespan in fruit flies by 14%, yet no one actually can reproduce that study. They can't get the same results. And if you can't get the same results, it's not real science. It's not actually showing an outcome, because if it was, it should be repeatable. It's that, plus it's the conditions are the same. It's 3 labs verifying the findings. So it's like, if you pass that, there's obviously something pretty significant there.
Oh yeah, because you can look at the results from each lab and see that it had a benefit. Then you can look at the pooled results and see that you had a benefit. So that really gives you as good of an idea as you can that you had an impact. And then that corroborates all the other prior studies in worms and fruit flies and yeast that are conducted by different researchers, different labs. And so I think the preponderance of evidence shows that it does have a benefit. Then it just comes down to, dosing. And one interesting thing that I'll mention is I've seen various people online trying to translate, okay, this amount of astaxanthin was used in the ITP. They'll look at how much from a ppm, parts per million, concentration were used in what of astaxanthin was used in the chow in the feed for the mice in the study, and trying to translate that to humans and figure out, well, how much would I have to take to have the same benefit? Because sometimes that's the other thing, is you have a great study, but it's not practical to take the amount that was used in the study, especially if it's animals or in cell culture in test tubes. And so if you just try to translate, if you look at the amount that is in the chow and do like a direct translation, it would be a lot to consume. But fortunately, humans absorb astaxanthin much better. Well, first of all, there's already a standard scaling from animals to humans that is used for agents in general. If you're doing drug development, there's a body surface area conversion that looks at rodents or canines or et cetera to humans. But there's also an additional scaling factor because carotenoids are historically not as well absorbed in rodents compared to humans. And on top of that, what we have is actual blood level data in humans and from the ITP program. The ITP didn't measure blood levels of astaxanthin in the main part of the study, just because they couldn't be collecting blood. It's hard to take a lot of blood from mice, especially on this long-term type of study. But they did a pilot feeding study and measured the blood levels there. And based on those blood levels that they reported to us, I don't think those blood levels were not reported in the publication because it was just a preliminary pilot study. But based on that unpublished data, the plasma levels found in the mice is in the range of what we saw when we did, say, 2 capsules of 12 milligrams of our formulation, because we did a human pharmacokinetic or bioavailability study looking at our form of astaxanthin versus the form of astaxanthin from microalgae. And we were trying to compare the blood levels. But in terms of the blood levels that we got in that study at one dose of 2 12 milligram capsules, that was in a similar range of what you had from the mice in the ITP pilot study, and maybe even a little bit more. So it might be, the best guess might be 1 to 2 12 milligram capsules of our form of astaxanthin would probably translate to the similar blood levels that you saw in the ITP. And then whereas if you look at some of our other published research looking at various cardiovascular applications and things, those were higher doses and higher blood levels that we found and translated to in that cardiovascular human study that we did, where I mentioned we had reductions of oxidized LDL, et cetera. we did a low dose of 2 capsules a day, but a high dose of 8 capsules or 96 milligrams a day. And we had significantly higher blood levels, as you would imagine. And that probably translates more to the animal proof of concept studies that we did looking at various other areas. So it's certainly, there's a range of doses you could take. And so I think from a basic maintenance level or longevity, overall benefit, which you may or may not feel a benefit, but you hopefully would know that it's working at the cellular level to increase your longevity, hopefully, or at least improve your cellular health. That's probably a 1 to 2 capsule a day type of a dose, most likely based on the translation of plasma levels of astaxanthin. But then there's the more hardcore applications where you want to look at specific benefits to cardiovascular biomarkers or other athletic pursuits or endurance or recovery, where people have experimented with higher doses and found improved benefits, both in the clinical setting, like the cardiovascular study that we did, but anecdotally, there's a lot of people that utilize different doses. And for example, on our website, we have customer testimonials, and we added the option where people can include their dosage that they're taking, so people can search and filter by dose and see what people were reporting. And so it's a small sample size. You want to do an actual human study to know these things, but it's interesting, to see. So hopefully that gives some context for those that actually want to know, like, what could I actually do with the ITP results and translate it to my life and kind of real world applications.
Speaking of translating it to real world applications, Dave, how do you go about choosing a product? Because when I first started looking into this, I'm like, oh, just find the cheapest one. And then I realized it's a little more complicated than that. And there are a lot of confusing words of wisdom posted online about the differences between natural and synthetic, the differences between microencapsulation and liposomal forms, the powders versus if it comes in a soft gel. What are the things you should look for in a quality product?
Yeah. So first off, I'll say that we're believers in astaxanthin. And so we think if anyone is taking a form of astaxanthin, that's already a win. And so, we're happy for people to just know about astaxanthin and be taking it from any source, that's credible and of high quality. But for the most part, we believe that astaxanthin is astaxanthin. The data from the various forms is relevant. Once you get astaxanthin to the cell, the molecule is the molecule. And we can talk about some subtleties in terms of the isomers of the molecule. But for all intents and purposes, astaxanthin is astaxanthin. And when it gets to the cell, you have the important benefit. The key difference, though, is how you make it, how pure it is, and how well it's absorbed to actually get to the body. But once it gets to your cell, and if you adjust for the same amount in the cell, it's going to most likely have the same results. And so I've worked.
But Dave, I want to interrupt you really quickly because I know that is the case. If it's astaxanthin, it's astaxanthin. But there's a third-party report put out by now the supplement manufacturer, and they mentioned they did in-house testing, and they also used another third-party lab to verify. I think it was Alchemy Labs to verify the results of like 20 or 22 brands, popular brands sold on Amazon, and they came back with like 14 out of 22 of them had very low levels, and of the ones tested, like 92% had less than 1 milligram of astaxanthin, I think it was.
Yeah.
When the therapeutic dose is generally considered to be like 6 to 12 milligrams.
Mm-hmm. Yeah. So that's what I'm saying. The front end, so how you make it, how well it's absorbed, and actually the milligrams that you get in the capsule, that all matters, and those are differences. But if you were to take 12, capsules of the 1 milligram version, if you will, and one 12 milligram capsule, assuming it was formulated in the same way and, absorbed the same, in principle, once all that astaxanthin got to the cell, it should have the same effect. But yeah, you want to, in terms of picking a product, you want to have one that's produced well and actually is, consistent with what's on the label. And so to back up, I've worked on kind of both sides of the arena in terms of the microalgal production, so the microalgae that produce astaxanthin, which we talked about the salmon and shrimp and crab, but and how the plants co-evolved with carotenoids, but microalgae are in nature one of the most the best producers of astaxanthin. And so you'll have a particular strain of algae that is a green type of algae that is called Haematococcus pluvialis, and it's found in the wild, but people will farm it essentially either in open ponds or closed tubes. But I used to work at a company on the Big Island of Hawaii in Kona, where you have these big ponds dug into the lava fields, and you will grow the algae. And so it starts out life as green, and it's a green form of algae. But when the sunlight hits the algae, the algae would produce astaxanthin to defend against the UV light, and then it turns bright red. So people think of it as a red algae, but it's actually a green algae that produced astaxanthin and turned itself red. And so that is one of the best ways that you can essentially grow the astaxanthin, farm the astaxanthin. And most of the supplements on the market are derived from extracting astaxanthin from microalgae. And so I used to work in that space in the late 1990s, which for me was during high school as a summer job, and then just after high school as well. So I started pretty early, and so the joke internally is always that I started from the pond up, rather than the ground up. So I definitely have firsthand experience with that, and it certainly works. You can produce astaxanthin, you can extract it, but it is prone to contamination because in that case it's open air farmed astaxanthin, and so you have you have the volcano nearby, you have the airport nearby, birds, everything, and so it's exposed to the elements. But also just the act of growing the microalgae is hard. It's like high tech farming where you have PhDs that are doing the farming. It's very hard, and you may lose a batch and have to drain the whole pond and redo it, and so it's not super consistent. It's hard. It is prone to contamination. And you can do entirely closed systems. And there are others, like, for example, in Washington State, in the United States, as well as in Iceland, that have entirely closed systems that don't use the open pond. And that reduces the contamination risk. But in any case, once you produce the algae, you have to extract out the astaxanthin, and you're only going to get 5 or 10% astaxanthin. And then the other 95% is other stuff from the algae, which is not bad necessarily, but it's not giving you the benefit of the astaxanthin itself. And so that's something that is always going to happen when you have the microalgal forms. And we actually, after several years working in that space, thought this has really profound health benefits. At the time, there was less than 200 peer-reviewed papers. There are now more than 3,000. So it's been an explosion of research over the last 20 or so years, 25 years. But even at the time, it was very compelling in terms of its effects on, oxidative stress and inflammation and some of the preliminary studies. And so we wanted to develop it potentially as a pharmaceutical, because we thought that would be the best way to help as many people. Because if the FDA approves it and doctors prescribe it, you'll get widespread use. Whereas as a supplement, it's harder to market, because you have people that can market, crap, just because they have money or celebrities or other things. And so our initial approach was then to pursue pharmaceutical development. But it's very hard to take a plant extract through a drug process. And so we said, okay, let's try to produce this in the lab so that it's highly pure. It's just the astaxanthin molecule. It's not the other stuff from the algae. And that's something that the FDA can get on board with as a consistent molecule. And it could, follow their regulations for drug development and manufacturing. So we did that for many years and worked with manufacturers in Europe, for example, that have expertise with production of carotenoids at scale, and pursued that pathway for many years. And after a decade or so, we actually pivoted back to the consumer space, but brought the learnings of the pharmaceutical development and the very rigorous production to the consumer market. And so we have a form of astaxanthin that's produced by natural product total synthesis, which is also by shorthand called synthetic. But you are synthesizing the exact natural form of astaxanthin, the exact same molecule. And like I mentioned earlier, there are different isomers, which if you think of the molecule, if you look at the structure online, if you Google it, it kind of it's like a pipe cleaner. It's this long straight line, essentially, little squiggly line with these rings at the end. And those rings could be thought of as like hands, and you can have like a left hand or a right hand on either end of the molecule. You could have a left hand and a left hand, or a right hand and a right hand, or a left hand, right hand. And so the form that's in the algae is kind of like two left hands. The form that's in some crustaceans, maybe two right hands, or a mixture of a left and a right hand. So all the different forms are found in nature. If you look at other molecules, not astaxanthin, sometimes it really matters if you have the left hand or the right hand in terms of how it works or its safety. With astaxanthin, the mixture of all the isomers, which is referred to as a racemic mixture, where you have kind of a balanced amount of left hands and right hands, and mixture of the left and the rights, kind of 1 to 1 to 1 to 1 of each. That actually was shown to be very safe in robust toxicity studies. High dose, long-term toxicity studies showed that the mixture of the isomers produced synthetically was extremely safe and had no issues of clinical significance that were translatable to humans. And these are studies looking at overall toxicity, carcinogenicity, genotoxicity to the DNA, reproductive and developmental toxicity. It's a very extensive battery of safety testing, and was shown that all the isomers are safe. From an antioxidant standpoint, we have done studies, for example, showing that each individual isomer or the mixture of isomers has the same antioxidant capabilities. And we published that. And so it doesn't seem to have an effect on the efficacy or the safety. There is one study that was commissioned by the head of marketing, a non-scientist for a microalgal company about a decade ago, that was in test tubes that, to my knowledge, did not control for the same concentration of the natural versus the synthetic, because how you introduce it into the test system can vary depending on how you extract it or produce it and how it's formulated. But in that particular study, which we think of as probably a bogus study, if you look at it from a real kind of scientific standpoint, in that study, they showed that the microalgal form had superior antioxidant capacity or effect compared to synthetic. And so they started to propagate the idea that synthetic was inferior and didn't work. But that's not true, because we've, like I said, done studies showing all the different isomers, whether it's the left version or the right, or the mixture is good. We've done animal studies, we've done human studies. The ITP, the NIH funded study in longevity, that was with the synthetic, with the mixture of isomers. So I think it's proven that the synthetic works, and is safe. And to my point earlier, we think of astaxanthin as astaxanthin. So the data, I think if you take the microalgal form, that will help your longevity as well. And so I think the data is translatable, but again, it's about how you produce it. And so in the case of the synthetic that we produce, it's highly pure. It's just the astaxanthin molecule that you're getting. It's consistent. And then we can formulate it more easily than an extract of the algae. And so we formulate it in a way that allows for it to be really well absorbed. And so we use a starchy matrix to essentially take the crystalline astaxanthin that's produced, that if you just made it in the lab and then just put it in a capsule and try to take that, it wouldn't be absorbed, because it's so densely packed together. It's like a little brick that your body can't really absorb. But if you can disperse the astaxanthin into this cloudy, starchy matrix, where we take a little bit of food starch, that's kind of the substrate, that kind of like the cloud that the astaxanthin can stick to, and then a little bit of glucose syrup to kind of hold it all together, and a little bit of cornstarch just to make sure the little particles of the formulation don't actually clump and stick together. You get this really highly bioavailable form. And the amounts of the starch and the glucose syrup or the sugar are so low, it's negligible compared to what you would consume in the diet. Like from a sugar standpoint, it's less than a tenth of half a gram per serving, which is less than a tenth of the FDA's threshold for something to be, quote, sugar-free. Less than you would have in a cup of spinach or broccoli or kale. So it's virtually no sugar. The starch amount is milligrams versus you would consume grams of starches if you're actually eating them. So you will see those on the label, but that's there for a reason. They're because they provide the bioavailability benefits. And so we actually took the leading microalgal astaxanthin form on the market that's been around for 25 years, and got a group of human volunteers, gave them 2 12 milligram capsules of that microalgal astaxanthin, measured their blood levels, collected blood over 24 hours at multiple time points, sent it to the lab where we have highly precise analytical methods to quantify how much astaxanthin is in each plasma or blood sample, and then had them wash out for a week where they didn't consume any astaxanthin foods or supplements, then gave them 2 12 milligram capsules of our form of astaxanthin. the same people. So it's not even a different group of 5 people. It's the same exact people, and then did the same blood collection over 24 hours. And when we measured the blood levels, we got 3 times the amount of astaxanthin absorbed into the body, both at the maximum concentration, which was at 6 hours, and then the total exposure, which was, if you add up all the time points and do the area under that whole curve, that was also 3 times the blood levels. And so, like you talked about earlier, you want to make sure you're actually dosing the correct amount. So if you say it's 12 milligrams, you want to make sure it's 12 milligrams. And some other manufacturers or brands don't do that, which is a shame. In our case, we definitely include the 12, and we'll include some overage just to make sure that there's enough in the capsule. And so the most reputable brands, do the same. And I'm confident that, the top sellers on Amazon, like the top couple brands are probably, providing the label, meeting the label claim. But even if you actually get the 12 milligrams, like to your point, a lot of other brands, that are more obscure maybe don't even have that. But if you actually get the 12 milligrams in each capsule, which is the highest dose for the most part, there's a couple products that maybe have pushed the dose higher, but virtually all of the highest dose products are 12 milligrams per capsule. If you even have 12 milligrams and you compare head to head, in our case, we got 3 times the amount into the bloodstream. So just because you think you see a 12 milligram capsule, they're not the same. And so if you look at, say, on Amazon, the top couple selling brands of 12 milligram astaxanthin, those products may be $25, $30 or so for 50 or 60 capsules. Let's just say it's 60 capsules for $25. In our case, we have 60 capsules and it's $50. And so people may think, oh, wow, it's double the price, it's so expensive. But actually, if you have to take 3 times as many of the other form, you'd be paying $75, for that versus the 50 for ours. So I think if you look at actually milligrams of astaxanthin absorbed, it's gonna, we are actually more cost effective, than the other forms. And to your other point about there's different formulations, a lot of the products you'll find are suspended in various oils. Historically, it was like safflower oil was used, and then some of the more recently others have used like coconut oil or extra virgin olive oil, and that's probably a much better selection. There's been some other like liposomal formulations like you mentioned, and I don't know on that one. We haven't tested against that product. I don't know. They claim that it works well, and it might. But what I do know is that in our particular formulation, against the most commonly used microalgal form in kind of a probably a safflower oil, which I think was historically was used in that brand, that we got 3 times the blood levels. And so I think that knowing that our formulation was what was tested in the ITP, and that it's very rigorous from a purity and consistency standpoint is something that can give a lot of people comfort. And when we talk with doctors or other healthcare professionals who might be a bit hesitant to recommend or try supplements, they are often very impressed with the rigor of our manufacturing and the data. And so we've actually had really good success in that space. And so that's something that I hope can translate to health conscious consumers, which for the most part, you want natural, you want organic, you want as clean of a label as possible, et cetera, et cetera. But in this case, I think you have the best of both worlds, where you have a natural molecule, but you're producing it in the lab synthetically. But all that means is that you're making it highly pure, and it's rigorously tested, so it doesn't have heavy metals or residual solvents or anything like that. It's, everything is tested for to confirm that it's highly pure, and consistent every batch. And then you have the special formulation to make it really well absorbed. And then ultimately, once you get in the body, like I said, astaxanthin is astaxanthin, but it's much easier to take one of ours than 3 of another, or even if that might be not actually the 12 milligrams, like you said, you might have to take much more of the others to actually get the proper result. Final thing I'll mention is that because ours is a powder in a capsule, if someone doesn't want to swallow a pill, they can twist up in the capsule and put it in water. It's water dispersible. So they can put it into water or a shake, or other type of thing to mix it in. So that makes it kind of convenient to take in other forms. It also doesn't have any aftertaste or smell, which some of the microalgal products do have, kind of like that fish oil type of aftertaste or smell, which is not the astaxanthin. It's just the other extract from the algae that's there that must be carrying along some of that smell and taste that some people may experience with some of those other forms. So those are all benefits that you would get with our form. But again, we just want people to take astaxanthin. We think that's the best of all worlds, and we'll probably include microalgal forms in the future as well, just because we want to be able to offer a platform of astaxanthin products. Right now, we have our flagship form as our product that we think is scientifically the best. But we just want the world to know about astaxanthin, and in the future we'll probably offer multiple forms as well.
Mm-hmm. Dave, I'm not sure if I showed you this, but I actually did a deep dive research and roundup of a lot of the popular products that are a lot of the popular astaxanthin products. And I was surprised to see so many different fillers and potentially unhealthy oils and things in some of the number one, number two, number three big sellers on Amazon. So what you're speaking is true. And I also, to me, what I care most about is getting something that actually works. And it's hard to know which of the ones are doing it right and which ones are doing it wrong unless you actually shell out the money to have them all tested yourself. So to me, the third-party results, such as ITP and others, speak for themselves.
Agreed. Yeah, that way you don't have to believe us, or it's just like, third-party validation is important. And again, just a note on fillers. Like I said, we do use the starch, components and the glucose syrup, and so some people may look at that and be like, "Oh, you have fillers." That's actually there as a key functional purpose for bioavailability. And then, for example, we have vegetable stearate, which helps to lubricate the formulation as it flows into the capsules, which when we first developed the product, we didn't have. But then the beadlet formulation of the astaxanthin would get stuck around the rim of the capsule, which comes in two pieces. Then you fill it and then you kind of snap it together. And when it was stuck around the rim because it wasn't perfectly flowing in, you would have potential capsule breakage. Maybe not on the line, but it may crack. And then you put it into a bottle, and then ship it to a consumer. And then in transit, you might have a capsule that ultimately breaks. Then you have powder in a bottle or a pouch that is not in the capsule as it should. And so there's reasons why we have each ingredient. They're not just there as a filler, for example. But that is one thing that is important for people to understand, that each ingredient has a reason. We're not just putting fillers in just to fill up, to kind of reduce the amount of astaxanthin and fill it with something else, which apparently others do. I mean, that's I'm surprised but not surprised. It's unfortunate. It's disappointing. Hopefully everyone would just include the right amount and hopefully build the overall market.
I'm referring more to the food dyes that are completely unnecessary and just add visual appeal to make it red or caramel colored or different things like that. But
yeah, well, I mean, astaxanthin is a dye, a color, additive, if you will. I mean, in animal feed, astaxanthin. One side note: farm-raised salmon, people think about that as being dyed pink. It is dyed pink, but it's dyed pink with astaxanthin. So they get astaxanthin in the wild as part of their diet, but in the farm-raised conditions, they're fed a diet containing astaxanthin as well, and that's the reason why they're pink. They may not get as much as they would get in the wild, and there may be other reasons why farm-raised. There are pros and cons to wild versus farm-raised, but in terms of why they're pink, it's still because of astaxanthin. But yeah, I mean, you certainly want to have other artificial dyes in the product.
That's what I'm saying.
Yeah.
Under the inactive ingredients, the other ingredients, if it says red dye 40 or it says caramel color, things like that, it's like, you don't need that.
You don't need that. Yeah, exactly. So,
okay, really quick, we got to start winding this down. But I used to take krill oil because it naturally contains some astaxanthin, but when I did the math, it's pretty low.
Yeah, it's micrograms, which means less than a milligram of astaxanthin. So krill oil is great in terms of other health benefits and omegas, and it does have astaxanthin, so that's fine. But that's not going to be sufficient for your astaxanthin needs. And so you can certainly take a krill oil supplement, but you should also take astaxanthin as well. And you can get as much as possible from your diet by eating salmon or other astaxanthin containing foods. But again, it's hard because with salmon, there's different milligram amounts per different types of salmon. But the appearance is a good cue. So the redder it is, the more astaxanthin it'll have. And so, but even with that, you may have a few milligrams per a serving of salmon, up to 6 or 8 milligrams, or 10, depending on how big the piece of salmon is. But still, that's that'd be a lot of salmons to consume, and that's just to get approach what you might get from one capsule. And the results show that typically higher dosing is correlated with improved health benefits. And so, I guess if you ate a lot of salmon every day, maybe you could be good. But for the most part, I think a supplement would be great as an addition. And so, yeah, in addition to krill oil,
Yeah.
it certainly is not enough in the krill.
And just the red and pink fish, you're not going to get it from tilapia and other tuna and
Yeah.
things like that.
Yeah. The red and the pink, but salmon is the highest concentration for sure. But you'll also find it, just as an interesting side note or tidbit, that flamingos are pink because of astaxanthin in their diet from the little shrimp things that they eat. And so when they're born, they're gray or white, and then you'll see that as they eat their diet, then they turn pink. So it's another interesting appearance of astaxanthin in the wild.
Yeah. And then also really quickly, to get the most bang for your buck, you're going to want to take it with fat. And also, how long until you start seeing results? I've read different numbers online.
Yeah, so you definitely want to take it with a meal containing fats. And that's because astaxanthin is lipophilic, it's fat soluble. And so when your body is processing a meal containing fats, it has certain processes that allow the fats to be incorporated into the body. And astaxanthin, being fat soluble, can come along for the ride there. And so it helps promote the absorption of the astaxanthin when your body is kind of already, in gear, engine on to absorb those fats. So that's why you want to take it, even though our formulation is a water dispersible formulation. So it's a little bit counterintuitive. So like water dispersible formulation, but you want to have it with fats. The reason is, the hypothesis here is that, first of all, we tested it and it works. So we know that, but we would hypothesize that the water dispersibility of the formulation helps to disperse the astaxanthin into the gut fluid, so the gastrointestinal fluid, which is aqueous fluid. So if you can disperse the astaxanthin nicely throughout the gut fluid, and then have, as that fluid has the fats from your meal and that's being incorporated into your body, then astaxanthin can be nicely absorbed. Versus if it's all not nicely dispersed, it's probably going to be harder for your body to absorb it. So that is the way that we believe it is best absorbed. And certainly the studies show that taking it with a meal, and carotenoids in general are best absorbed with a meal. And then in terms of how long until you experience results, that's a hard one because it varies for different people. It varies, first of all, based on what dose they're taking. It varies on what type of health benefit they are looking to achieve. How healthy they are. And so some people have felt benefits within the first day or few days in terms of joint, relief, or how their joints or back is feeling. And others, don't feel something for weeks or months. In terms of our clinical study looking at the cardiovascular biomarkers, that was a 12-week study. And so 3 months was the result. And most of when we looked at the non-clinical or preclinical studies, various animal models looking at different health benefits, those are often 8 or 12-week studies, and other human clinical studies are often 4, 8, 12 weeks. So I think the best thing is to give yourself 1 to 3 months, ideally 3 months, to gauge how it's working. And then you can actually not just binary make a decision, worked or didn't work. You can actually adjust your dose at that point as well, and maybe go up or down and see if how the results are, and then give yourself another 1 to 3 months, and so you can kind of titrate and find the dose that works best for you. But if someone is really healthy, they may not feel a benefit, but you could think of it as insurance, or as something that is helping your cells function normally, hopefully. And over the long haul, that's really important. And because aging happens over decades, and that chronic inflammation, oxidative stress that wreaks havoc throughout your body over decades is something that, if you can mitigate that, that can hopefully have really profound benefits over that long term. And so I think it's something that, whether you feel it or not, you should be taking. And if you do feel it, that's just a cherry on top, which, you may experience joint and muscle benefits, cognitive benefits, skin benefits. And so there's things, energy levels or mental clarity. There are things that you can feel and try to assess on your own. Then there's things you can measure. And so getting your blood work done every 3 years, 6 months, or 12 months, then you can look at your various cardiovascular or inflammatory biomarkers, liver biomarkers, cognitive, et cetera. And those are things that you could actually measure. So I think that's the best way to approach it. Unfortunately, it's not just like, oh yeah, wait 1 week and then you're good. That would be great, but it varies amongst individuals.
Awesome. Well, Dave, people want to connect with you to give AX3 a shot. How do they go about that?
Our website is ax3.life. Our Instagram is also at ax3.life. And they can check it out there. And that's the best way, to start off with astaxanthin. And then they can learn a lot more. And so I think things like the conversation we're having and other, content is a great way to learn about astaxanthin. And so I think the more you dig, the more interesting it is. And hopefully people can try it themselves and help to spread the word, because this should be as well known as omega-3s or other common supplements. This should be, something that everyone thinks of as a foundational supplement for health and longevity.
Guys, if you want to give us a shot, you can use my code, which Dave's team set up. It's Urban, and that'll save you 20% on your order. And I'll put a link to that in the show notes, as well as the article I did on astaxanthin supplements. And Dave, thank you so much for joining me on the podcast. It's been a blast discussing all things astaxanthin and why this is a molecule that more people should know about.
Cool. Thanks for having me. It was great to discuss with you.
I hope that this has been helpful for you. If you enjoyed it, subscribe and hit the thumbs up. I love knowing who's in the 1% committed to reaching their full potential. Comment 1% below so that I know who you are. For all the resources and links, meet me on my website at mindbodypeak.com. I appreciate you and look forward to connecting with you. As a reminder, the information depicted in this video is for information purposes only. Please consult your primary healthcare professional before making any lifestyle changes.